question. So the first question is this one. Now I have to alter the question a little bit, right? Let me just alter it here a little bit. 1 second, right? So my mouse is giving a little bit of trouble. Right. So cos squared x. All right, so what you have to do in a proof question, you have to choose, well, the more complicated side, which is in today's question is the left-hand side, and you have to alter it using the rules of trigonometry to get the right-hand side. So get started, guys. And of course, you won't be able to send your answer for this one, but at least let me know when you are finished or you were able to prove it. Good luck and keep me up to date. This question, you need to know your trigonometry rules. For example, well, one common rule in ADMATS is that tan theta, right, is equal to sine theta divided by cos theta. So anywhere I guess in maths, you see a tan theta, you could throw away tan theta and replace it with sine over cosine. That's allowed in maths. And you could transpose this formula anyhow you want. Another formula, another popular formula is this one. Sine squared theta plus cos squared theta is equal to 1. So that means in maths, wherever you see sine squared plus cos squared, you could throw that away and replace it with 1 or vice versa. If you see the number 1 and you just want to get rid of it, you could throw away the number 1 and replace it with this. The formulas can be transposed. For example, if I throw across the sine squared theta, so are we left with cos squared theta on this side? If I throw across positive sine squared theta, I will get minus sine squared theta. So if in maths I see a cos squared theta and I don't like it, I could throw him away and replace him with 1 minus sine squared theta, or even vice versa. I think this one is going to come into play today. So let's see. What you want to do is choose the left-hand side of the equation. I have it here. And they gave us two fractions to add. So let's add the two fractions. We have to find the LCM. The LCM of 1 plus sine x and 1 minus sine x that's a complicated LCM. So all you have to do is put back the underneath. I think I showed you all this trick already. And like if you have two numbers, right? Like 1 over 2 plus 1 over 3. The LCM of 2 and 3 is 6. But you don't have to put 6. You can just take the two denominators and just multiply them. That will also work. I know 2 by 3 is 6. So in other words, if you have 1 over x plus 1 over 8, and you have to add these two fractions and you don't know what the LCM is, not a problem. The LCM would be x multiplied by 8, or x8. You just take the two denominators and multiply them. And the beauty about this is that x into this, you notice these two match up, it always leaves you with the other one. So x into this will leave you with 8. 8 multiplied by 1 is 8. 8 into this, the 8 and the 8 match up. It always leaves you with the other part. So 8 into this is x. X by 1 is x. So it's the same concept here. 1 plus sine x into this. You notice the 1 plus sine x matches up with the 1 plus sine x. So it leaves you with the other part of the LCM. So this into this leaves you with 1 minus sine x. 1 minus sine x multiplied by 1 is 1 minus sine x. 1 minus sine x into this LCM, this and this match up, so it leaves you with the other part. So you're left with 1 plus sine x. You multiply by the numerator, which happens to be 1. And when you multiply anything by 1, you get itself. Right. So do me a favor. Simplify the top and multiply out the underneath. Expand the brackets underneath. And I guarantee you, when you simplify this as much as possible, you will end up with this expression. And once you end up with this expression, you are finished. You have completed the proof. You have proven the identity. Good luck and let me know when you are finished. So let's do some simplification here. The underneath, well, the top is real easy. The 1 and 1 is 2. So 1 plus 1 is 2. That's easy. The minus sine x and plus sine x will cancel out, right? Because if you have minus sine 1 sine x and positive 1 sine x, you get 0, right? The underneath now, if you take your time and multiply out the underneath, you will get 1 minus sine squared x. You all notice this here is the difference between two squares, right? It's the same format, right? So you end up with 1 minus sine squared. And the question is basically finished here. Because anywhere in maths, you see 1 minus sine squared, and we have 1 minus sine squared. It's perfectly okay to throw it away and replace it with cos squared x. It looks exactly like the right-hand side. Hence, it is proven, right? In the exam, you have to write a sentence. Hence, it is proven, right? Or hence, the identity has been proved, but write a sentence afterwards. Right, so for those who got it wrong, you think you understand it now? All right, let's move on. Let's try another. Here's another question, but I have to alter it a little bit so it fits the format of the CSEC syllabus, right? So give me a few seconds. Right, so get started. I alter it to make it seem like the CSEC syllabus. So choose this side. Let me box it off. Use your trigonometry rules and make it look like the other side. Good luck. Remember this formula that I just mentioned, that tan theta, anywhere you see tan theta, it's the same exact thing as sine divided by cosine. So I just say, anywhere, it could work reversed as well. So anywhere you see sine divided by cosine, not a problem. You could throw it away if you wish and replace it with tan theta. So this is the formula that you actually need. So let's multiply out these brackets. So this might be a little troublesome to multiply. I am assuming that this fraction is given a little bit of problems, but let's do it the old-fashioned way. When you have to multiply out brackets like this, you're supposed to take the first bracket and multiply it by the first item. So let's do that. You're going to take 1 plus 1 on sine x and multiply everyone in these brackets by 1. And then you're going to take back the first brackets and multiply by the second item. So everyone in these brackets gets multiplied by minus sine x now. So we're going to take the minus sine x and multiply by 1 plus sine x. Everybody okay so far? This is how we multiply out a pair of brackets. So this bracket is easy. Anybody multiplied by 1 is itself. So we end up with 1 plus 1 on sine x. All right. Then everyone is going to get multiplied by minus sine x. Minus sine x by 1 is minus sine x. And then minus sine x by positive. Remember, this minus sine x is going to get multiplied by the top. So minus sine x by 1 is minus sine x. And then we divide it by who? Sine x. But when you divide two same things, you get how much? 1, right? So we end up with 1 plus 1 on sine x minus sine x minus how much? 1. Won't this one and this one cancel out each other? Because 1 minus 1 is how much? 0. So let's move up here and continue, right? So we have 1 on sine x minus sine x because the ones have canceled out each other. Sine x is the same thing as sine x on 1. Let's add up these two. Let's find the LCM. The LCM here is obviously sine x. Sine x into sine x is 1. 1 by 1 is 1. Minus 1 into sine x is sine x. Sine x multiplied by another sine x is sine squared x. And now realize we needed two formulas, but that's okay. Didn't we meet this formula over here in the previous question? What can we replace 1 minus sine squared x with, the top part? What can we replace that with? Let's look back in the notes. Right, Salamatu, correct. Anybody else seen it? 1 minus sine squared x from the previous question, right, can be replaced with cos squared x over, and of course we have sine x. So we throw away the whole top and replace it with cos squared x. So now we have cos squared x divided by sine x. Now it doesn't look like this as yet, but look at this. Isn't cos squared x the same thing as cos x multiplied by another cos x? Cos x by cos x is cos squared x divided by what? Sine x. The answer is in front of you. 1 cosine divided by 1. Check it out. The cosine is on top, right? Sine divided by cosine is tan. So it would make sense that if you flip it around, right? Like if the cosine was on top and the sine is underneath. Let's see, I'll run out of space here. I'm going to write underneath here a little bit, right? In maths, remember, whatever you do to one side, you can do it to the other side, right? So if I have tan x is equal to sine x on cos x, remember tan x is the same thing as tan x on 1. In maths, if I flip this side, I could do anything. I could flip this side. I just have to make sure and do the same thing to the other side. So if I have sine x on cos x and I flip that, I have cos x on top and sine x underneath. If I flip this side, then by maths, I can flip the other side. So cosine divided by sine is how much? 1 on tan. The tan will end up underneath the cosine. Right. Everyone seen it now that I've just proved it? Cosine divided by sine will give us the tan underneath. Right, so I'll run another space here. So when you replace this, you end up with cos x divided by tan x. I just did the proof. All right, so this here is a kinematics question. Now, I couldn't resist this question, right? It's a really good question. This question, how is kinematics? It deals with displacement, right? Now, in a displacement time graph, right? In a not distance time graph, and remember, displacement and distance is different. In a displacement time graph, if you were to find the gradient, what does the gradient tell you? Let me know on the chat. If you have a displacement time graph and you were to find the gradient at any point on the graph, what information does the gradient tell you? Brito, correct. It's supposed to tell you velocity. So the gradient gives you the velocity. Now remember, velocity and speed is kind of similar, but velocity and speed are different. Remember, velocity is a vector quantity. It can either be positive or negative. So velocity could be a positive value, and sometimes it could be a negative value. A positive velocity means it's the object is traveling in one direction, but if the velocity becomes negative, that means it's traveling in the opposite direction, right? So positive and negative velocity could indicate the direction of the object. Quick question before we move on, and let's give it as much hints as I could. You see this straight line here? I'm going to put 3 points, A, B, and C. Is the gradient at A, B, and C different? What do you all think? If I were to find the gradient at point A, and then the gradient at point B, and let's just say the gradient at point C, will I get the same answer or a different answer for the gradient? All 3 points has the same exact gradient. So I just saying, if the gradient at point A was 6, I just saying if the gradient at point B would also be 6, and the gradient at point C is also 6. Because this is a straight line, the gradient at any point on this line will be the same. Now, after the line changes into a completely different direction, then the gradient of all these x points will also be the same. It will be different to the original line, but the gradient at any point on this line would be the same. So the moral of the story is once you have a straight line, the gradient at any point on that same straight line will always have the same value. Using all of those hints, let's see if we can get through this question. I think it has 2 parts to this question. So good luck, and we'll see what you guys come up with. So let's draw out this scenario. Remember, displacement is always being measured from the original position. So let's say we have let me make it a little colorful for you guys. Let me say we have a meadow, right? So we have a meadow over here, nice grass here and whatnot, right? And you have a person here, right? So his name is, let's call him Jim, right? And let's say he starts his journey over here. I'm just going to call this point A, right? So this is at the beginning over here, at the beginning of the journey. Remember, displacement is a vector quantity. So let's see what happens. In the first 10 seconds, look at here, in the first 10 seconds, his displacement is 50, and it's positive 50. So let's just choose a direction to be positive. Let's just choose to the right to be positive. So for the first 10 seconds, he walks 50 meters. So he now walks 50 meters. That's in the first 10 seconds. Then, after this point here, you notice his displacement is getting lower and lower. For those who have not seen it, his displacement at this point is 50. And at this point, his displacement is how much? 40. And just do one more. As we go lower, the displacement is now 30. Remember, displacement is measured from the original position. So eventually, his displacement at this point here becomes how much? At 35 seconds, his displacement is 0. So that means he has walked back to his original position. So that means he has to walk back 50 at point A for his displacement to be 0. Remember, I don't care that he walked 100 meters. He walked 50 this way, and then he walked 50 back. His displacement is now 0 because he's back at the original point. But then he decides to walk some more. And at the 40th second, his displacement is minus 10, which means he has walked behind his original position. So at the end of the question, I know they didn't ask this question. At the end of the question, at the end of the 40 seconds, his displacement is minus 10 because he ends up 10 meters behind where he started. But the question didn't ask that. They asked for the distance. In distance, you just add up all of them. You don't care if it's positive or negative. You just treat all the values as positive. So do you all think you can get the correct answer now? What is his distance? Count how much meters he actually walked, and you will get the distance. He walked 50, then 50 back, and then 10. What's his total distance in this case? Right, the answer to this question is 110 meters. Right? Right. This could also help you with physics. For those who are physics, a question like this could also come in the physics exam. So there's a little crossover between physics and AdMaths for the CXC syllabus. Right. On the axis, draw the corresponding velocity time graph, right? So you could just take a look at this, right? So the y-axis is going up to 6 and down to -6, and the x-axis is going up to 40 seconds, right? Let me just go back to the previous chart, right? You will need to actually see this graph in order to do the other one, but I'll draw a makeshift version of it, right? They want you to draw the velocity, right? Well, let me do this one for you because I have to go back and forth. Quick question. Remember at the beginning of this question, I asked you, what does the gradient represent? Doesn't the gradient represent the velocity? So could you all find the velocity of the black line and then find the velocity of the pink line? I could draw that. Sorry about that, right? But do me a favor. You have two lines to find the velocity of. I'm really asking you to find the gradient of both lines. So let me rephrase it. Find the gradient of the black line, send your answer, and then find the gradient of the pink line and send your answer. Right? All you have to do is choose 2 points. So the gradient of the first line, for the first 10 seconds, I'm getting 5 meters per second. And for the other line, I'm getting this, obviously get a negative value, right? -2 meters per second. Just make sure you see those. A lot of people did send the correct answers, right? So for the first 10 seconds, the velocity is 5 and a constant value of 5. And then for the remainder of the journey, the velocity is -2. So how are we going to draw this on the next graph? Remember, this graph, the y-axis is velocity. For the first 10 seconds, isn't the velocity 5? So I'll draw it here in pink. And then for the remainder of the journey, the velocity is -2. So after 10 seconds, you just go down to -2 and draw a straight line all the way to 40. I know it looks weird, but this is the graph the examiner wants. Because for the first 10 seconds, the velocity is 5, and then it switches almost immediately to a velocity of -2, indicating that the object has reversed or is going the opposite direction. Right? Leave that for 20 seconds. So you could connect it, but if you won't get any, I don't think you'll get any extra marks for connecting it. But yeah, if you want to put a vertical line going down here, you could. All right, let's move on. All right. Draw a box and whisker diagram for the data below. Good luck. All right, so you're going to need 10 minutes for this one. Go back to your notes and look at your box and whisker diagram notes, right? You're going to have to find things like Q1 and Q2 and Q3, first quartile, second quartile, and third quartile, right? The numbers have already been arranged from smallest to largest. So when you're doing a box and whisker, you have to find Q1 first. Well, you can find them in any order, but I usually like to find Q1 first. And to find Q1, we use n plus 1 divided by what? 4. And you put a little TH here because it shows you the position of the answer. So we have 14 values in all. So we're replacing the letter N, the capital N there with 14. So if you replace this with 14, 14 plus 1 is 15. 15 divided by 4 is 3.75. So the Q1 is in the 3.75 position. So it's not in the third position and it's not in the fourth position. It's in between the third and fourth position. Here's first, second, third. So this is third place and this is fourth place. So you have to find the value that's in between the 8 and the 10 because 3.75 is in between. You add the two values and divide by 2. 8 plus 8 is 16. 16 divided by 2 is 8. So Q1, I'll write it over here. I'll write it in pink, is 8. To find Q2, right, you're using this formula, n plus 1 divided by 2. And you apply the same concept. This formula will give you the position of Q2, better known as your second quartile or your median. Q3 is n plus 1. You multiply the top by 3 and divide it by 4. And you apply the same concept. Right, so apply the same concept for all 3 of them. Send your answers across. I know you're doing it, right? And then I will reveal my answers. Go ahead and. So for Q2, you're replacing here with 14 again. 14 plus 1 is what? 15. 15 divided by 2 is 7.5. So Q2 is in the 7.5th position. It's in between the 7th and 8th position. 1, 2, 3, 4, 5, 6, 7. Here's the 7th position. Here's the 8th position. What value lies in between those two values, right? So 23 plus 33, add those two and then divide it by 2. I'm getting 28. So my Q2 value seems to be 28. A lot of different answers for Q3, but anyway, let's go ahead and do this. So we replace it here with 14 again, right? So we say 14 plus 1, that's 15, multiplied by 3, and then divided by 4. So 15 multiplied by 3 divided by 4 is 11.25. So Q3 is in between the 11th and 12th position. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th position and 12th position. Who lives in between those two? Add 45 and 50 and divide it by 2. I'm getting 47.5. Right, so I think a few people need to check Q3. Right. So let's draw the box and whisker diagram now. I already have the axes laid out here. So for our box and whisker diagram, you need the lowest value. 5 is the lowest value, and you need the highest value, which is 15. So the box and whisker starts at the lowest value, right? Which is 5, and it ends at where? 65. That's over here. And where is Q1? You put little lines for Q1, Q2, and Q3. Let's try our best to approximate it, right? Q1 is 8. So here's 5 and here's 10. I don't have a proper graph paper here, right? But let's call this 8. That looks like about 8. Q2 is 28. Look for 28. That'll be in between the 25 and 30. And Q3 is 47.5. Look for 47.5. That will be somewhere here. These three, make a box out of it, right? And then draw lines coming out of it, the whiskers to the lowest and highest point. So this line here is Q1, this one represents Q2, and this one represents Q3. How much have you all had the drawing as well, right? So, right, so take a 2 minutes, draw it out. Let me know when you are finished. All right, let's get ready to move on. 5. Anybody disagrees with my Q3 answer? Let me just do back this calculation to make sure. Next thing I did something wrong because I find it hard to believe the computer program was wrong. 14 plus 1 multiplied by 3 divided by 4, 11.25. So let me count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nana, our answer on the that we calculated is correct. All right, so let's move on. All right, so you have to find the variance of this information. Everyone draw back this table, and I'm going to give you a full 15 minutes with this. And I have the formula downstairs here, right? You figure out which formula you need to use. These formulas are given to you in the exam. So I want you all to use this as a revision exercise. I want you to go back in your notes and give it your best attempt. 15 minutes, the clock is ticking. For the midpoints, right, let's make sure we have 25 here, 55.5, 65.5, and 75.5. All right. Now, the first thing you need to do is find the mean, right? Remember, to find the mean is sigma fx divided by sigma f, right? That's the x with a little dash on top of it. So, and you have to use the second formula because there's a frequency involved. If there was no frequency involved, you would use the first formula to find the variance. Right? So I hope everyone is on the correct track so far. At least. So to calculate the mean, we need the fx value. Now, the midpoints are considered x, and you have the frequency. So you take in the frequency values and multiply it by the corresponding x values. So for the fx column, I'm getting 25, 166.5, 262, and 151. So you have almost all the information here. You have to add up the fx column. That will give you the sigma fx. And then add up the frequency column. For the frequency column, the total is 10. That's easy to do. You can add up these things. You'll get 10 here. And for the FX column, well, somebody said they get in, and I agree, 604.5. So if I take the 604.5 and divide it by 10, that means my mean is 60.45. Right, but that's only piece of the question now, eh? You have to do the rest of it. That you have to find fx squared and divide it by sigma f, and then throw all the values into the formula at the end of the question. And here, x squared values, let's see what I have here. I got 625, 3080.25. 4290.25, and the last one is 22801. And to get the fx squared, I take the x squared and just multiply by the regular boring f values. Okay, so what if I did this correct, right? So I'm getting 625 here again. You get some huge values there, 9240.75. 17161, and last 456. Anybody else could agree with these answers? No, I'm human, just like you guys. I can make a mistake, right? Someone is disagreeing with the last answer. It seems that I made a mistake, right? The last one is wrong. I am getting 5700.25 now. Now, if I take that now and multiply it x squared by f, which is 2, I am getting 11400. Correct now? 0.5. I'm looking about correct here now. All right. So it's a good thing you all double checked my work. See if you can finish off the question now. So I'm writing the mean up here because I need the space down here. So to find the variance, apparently, let's see. It's hard to get space here. We're supposed to take sigma fx squared. So I'm supposed to add up everybody in this column to get sigma fx squared. So it's 625 plus 9240.75 plus 17161 plus 11400. I hope I have this correct here for sigma f in the yellow spot here. 38,427.25. I'm reading other people's answers. Great. Yes. So let's throw it into this formula. Sigma fx squared is 38,427.25 divided by sigma f. Sigma f is 10 minus the mean squared. Remember, this is the mean, but we have to square it before we minus it. Right? So I think I can work out this straight on my calculator. Minus 60.45 close bracket squared. I'm getting this. Correct me if I'm wrong. 188.522. Obviously, we can round this off to 2 decimal places, but the answer would be in meters. Yep, because it's the variance meters. Let me know if you guys are getting something very close to that. Gordon. Remember, we just found the variance. If they ask you to find the standard deviation, you just have to square root the variance. So if they had asked you to find the standard deviation, you'll just square root this, and whatever you get would be the standard deviation.